I think the biggest challenge we've got with modelling is being able to explain it to decision makers. The modelling itself provides lots of information and is becoming more critical to inform the evidence base for decision makers. So being able to effectively communicate what that modeling's showing, the uncertainty, the assumptions you're making, the risks that's within that is really key for me moving forward. Flood modelling is one of the key tools we use in the Environment Agency. So seeing some of the innovation that's happening within the tool to make ourselves more efficient and effective in using it is really quite exciting.
I think clear communication is needed. Flood risk can be something that's hard to communicate with a range of end users. You've got technical users right down to the general public who just need to know whether they're at risk or not, and whether they need to prepare. Flood modeller, it's been around for a long time, so there's plenty of industry expertise, plenty of people who you can lean on to help you to solve the problems, but increasingly the tools are becoming even easier to use. The data's there at your fingertips.
I think there are three kind of main big challenges really. The key one is climate change and the impact that has on the uncertainties and the impact of climate change projections, the number of scenarios we need to then run because of that. The second one is big data that comes out of that. There's just so much information out there that we need to then process, analyse and report, and that's becoming even more important than I think actually building the models. And then the third one I think is testing options in an efficient way for business cases. So they've got to obviously relate together, and I think a lot of that comes down to the number of scenarios that you're actually then having to look at. Flood Modeller, I think for me, creates a really great space to not only build the models, but also to analyse the outputs from those. So it has that interface where you can then look at the results that you're using in a way that means you can compare before and after scenarios and then build lots of multiple scenarios together to run all those different combinations of climate change and options for your flood defence scheme, etc.
I think some of the biggest changes that we've got is uncertainty. So we've got uncertainty in the climate, we've got uncertainty in all the data that we're using, in the models that we create, and contrasting that, we've also got a greater drive for certainty. We're asking for greater tolerances, we are looking at bigger schemes, bigger impacts on people. We need to understand with greater certainty what our evidence base is showing us so that we can make real impacts and undertake actions to protect people in the environment. I think Flood Modeller helps us address challenges like this by being a tool that we can use to look at the whole range of evidence for flooding. We can produce lots of scenarios, lots of evidence that we can analyse to help tell a story about the flooding in a location. And that then helps us to drive the actions that we can take to protect people in the environment, to reduce that impact, reduce the impact of that uncertainty that we see.
So I think one of the biggest challenges which I've noticed lately is the kind of the disparate sources of modelling we have nowadays. When you start a project, it's kind of trying to find all the different models and all the history of those models as well, because some data may have been lost over time, or it may be that kind of you have a very old model which hasn't been updated and you're being asked to use this without an update. So kind of using those data sources and actually trying to bring them all together is kind of one of the biggest challenges I've seen so far. Flood Modeller's kind of been an industry standard for quite a while now. It's quite good to bring it all into a central system. It kind of brings everything together, and it hopefully helps us bring up all the sources together and actually gives kind of one source of truth.
I think one of the challenges is now there's so much we can be doing with modelling. There's so much more detail we could be adding into the models. There's so many more simulations that we can be running. And I think our challenge is stopping and thinking about what we should actually be doing. How much detail should we be adding? How many simulations? How long should they be? What outputs do we want? What resolution do we want those outputs? One of the benefits of Flood Modeller is the organisation that's in there, the way that you can stack up simulations. You can look at the results of different simulations together and compare them, and the audits and the management of data that comes within that. And that's been developing over the last few iterations of Flood Modeller, and it's great to see today how it's going to be developed further.
There are some great features, and new features coming into Flood Modeler will help address these challenges. Hydrology Plus will be an absolute change to how we work. There are challenges and barriers to getting the right data and the right software at the right time. Hydrology Plus removes all these barriers. It should be a far more enjoyable experience for our users. They should be able to work through the whole chain from data collection through analysis, through hydraulic modelling, through deliverable production a lot more smoothly. There's huge efficiency in what we're doing, and it just removes the barriers and the frustrations our users have faced for years in doing this sort of work. And it's a real step forward. I'm really happy to see it coming in. The GPU solver is an immense step forward in speed, so models which previously would have taken days or even longer to run can now run in a matter of seconds. It's phenomenal. So we can do more iterative work. When we're looking at building solutions, we can test lots of solutions in the space of an hour. Previously that would have taken a week. Now we can do that same work in a couple of hours. It speeds things along. It also lets us bring GPU technology, 2D technology into a forecasting environment. So for years we've been using pure 1D models in forecasting because they're quick. We can now use 2D models to give us far richer data, and it opens up possibilities for operational forecasting.